What is an ellipse? Ellipse is the figure produced when the cone is cut by a plane at an angle that is not parallel to the base of the cone. In the picture presented, observe how the cone is cut by the plane and what kind of figure is produced on the graph. Now, how is an ellipse defined in geometry? Ellipse is the set of all points with coordinates x and y on a plane such that the sum of their distances from two fixed points is constant. These two fixed points are called foci, or focus in singular. In the figure below, we have the graph of an ellipse with foci 1 and 2. Now, to graph an ellipse, there are important parts that we need to familiarize. First is the vertices. V sub 1 and V sub 2 represents the vertices of our ellipse. Second is the major axis. The major axis is the distance between vertex 1 and vertex 2. Sometimes it is called the longest diameter of the ellipse. Now, half of the major axis is what we call the semi-major axis, represented by variable a in our formula, which I will discuss to you later. The next part is the covertices, represented by w sub 1 and w sub 2. The distance between covertex 1 and covertex 2 is what we call the minor axis. Sometimes it is called the shortest diameter. Now, half of this minor axis is what we call the semi-minor axis, represented by the variable b in our formula. Lastly, we have the focal length, represented by variable c. The focal length is the distance from the center to the focal point, or the focus. Now, if you know these values and their location, graphing our ellipse will be easy. Let us now proceed to the equation of the ellipse. Case number 1. If the ellipse has its center at the point of origin, 0, 0, the equations are: type 1, we have x squared over a squared plus y squared over b squared equals 1. For type 2, we have x squared over b squared plus y squared over a squared equals 1. In both cases, a is greater than b, and b is not equal to 0. Now, looking at the two equations, you will notice that they are almost the same, except that their denominators were interchanged. In equation 1, the bigger denominator, a squared, is under x, while in the second equation, it is under y. Now, we should take note of this because it significantly affects the orientation of our graph. If x has the bigger denominator, the orientation of our ellipse is horizontal, meaning it aligns with the x-axis. But if y has the bigger denominator, the orientation of our ellipse is vertical. This means that our graph will align with the y-axis. Case number 2 is when the ellipse has its center not at the point of origin, or at point hk. The equations are: type 3, quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. And Type 4, quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Still, in both cases, a is greater than b, and b is not equal to 0. Again, notice that the two formulas are almost the same, except for the location of the a squared, or the bigger denominator. Now, just like in our first two equations, if x has the bigger denominator, our graph is horizontal. It will align itself with the x-axis. If y has the bigger denominator, our graph would be vertical. So, as simple as that. I hope you have a better understanding now of the ellipse and its equations. In my next video, I will share to you how to graph the ellipse. So I hope you have already subscribed to my channel so that you'll be notified when I upload my next video. Until next time, thank you so much for watching. Bye!